right, so this is the 12-1 through 12-4 fat twin, and I call it a fat twin because if you've ever seen a pair of twins, one of them's just a little bit fatter than the other, aren't they? And this is the fat one, all right? So the first one up here is a probability question. It's about Billy and Bobby. They went going in a contest, and we want to know the probability that they win first or second. And I'm going to show you two different ways of doing this. You need to think about order. It could be Billy and Bobby getting first and second, or vice versa, and there's the word or, it could be Bobby and Billy who would get first and then second. Okay, so let's approach it from this point of view. The chance of Billy getting first is 1 in 100. A ticket has been pulled, so now the chance of Bobby getting second is now 1 in 99. Or, which means add. I could reverse the order, and now Bobby gets first, which is 1 in 100, times 1 in 99. Now this ends up being 1 over 9,990 plus another 1 over 9,990, or just 1,900. I can't speak, I'm sorry. 9,900, which is 2 in 9,900. Now, if I push some buttons on a calculator there, 2 divided by 9,900, I get that. Convert it to a percent, multiply by 100, 0.0202. That's one way of doing it. The other way may or may not make more sense to you. But the question is that order matters. You need to understand that because I can be first and second. It's a ranked idea. So here's another way of doing it. How many ways can I pick 2 people to win 2 prizes? That's legit 2 pick 2. Over how many ways or how many groupings of 2 where order matters out of 100 people? Over 100 pick 2. If you understand permutations, this is the quick way, but you still have to look at the context of the problem and decide order is important. And this might be the way you like. I'm this stuff right here. This is how I think. I haven't quite got my mind wrapped around all this yet, and I've done this for a long time, but I still like this stuff. You pick your pill, I don't care. Anyways, let's just see if it's the same. We do 2, math, probability, pick 2, and we get 2 because there's only 2 ways that event can happen, so you shouldn't be surprised. There's your 2. And then we do 100, math, probability, pick 2, and there's that 9,900. You see it? So 2 over 9,900 is the same old decimal. If I want to make it a percentage, I can move the decimal 4 places, or I can just multiply it by 100. 0.0202. Same thing. All right, a math teacher uses delta math to assign extra work, and I almost did that this year. On a recent test, 48% of his students passed the test. 62% of all his students used delta math. 78% of the students who passed the test also used delta math. Find the probability that a student passed the test given they used delta. I always focus on this part. This is the probability of passing given delta. Now the numerator's got to be the and statement, passing and delta. The denominator is the probability of using delta. And, you need to write this out, kids. A lot of you don't, and that's your issue. You refuse to do this. That's your issue. You're just plain lazy. All right, so passing and using delta. 78% of the students who passed used delta. You see it right there? Passing and delta is 78%. This problem needs to be rewritten because it won't work. So let's make this 83. So we got 78% over 83%. 0.9397. It's roughly a 94% chance of passing, given you use delta math. Hopefully you understand why I had to rewrite that real quick. And let's go ahead and fix that real quick before I forget. That's number 2. Hopefully you guys won't see the mistake. I believe I changed that to an 83. And we're good to go. All right, moving forward to number 3, find the missing probability. It says assume A and B are independent. You are supposed to find the probability of A or B and the probability of A and B. If independent, it's probability of A plus the probability of B for an or. If it's an and, it's the probability of A times the probability of B. All right, so let's do the probability of A or B. It's going to be 0.25 plus 0.46, which is 0.71. Let's do the probability of the and statement. And means multiply. If events are independent, it's 0.25 times 0.46, which is point what? 0.115. I'm missing a decimal place. No. 0.115 should be the right answer. I'm pretty tired. My brain's not what it used to be. Yeah, all right, cool. 0.115. Assume A and B have overlap. Okay, so if they have overlap, the probability of A or B is going to be the probability of A plus the probability of B minus the probability of both. Okay, so I want to find this one. I want to find A or B because that's the word for or. And that, by the way, means and. So it's going to be 0.4 plus 0.3 minus 0.15, which is going to be 0.7. 0.7 take away 15, or think about 70 take away 15, whatever. It's 0.55. Assume A and B have overlapped, and they gave me the and one right here. I'm supposed to find that one. The probability of A and B is going to be the probability of event A plus the probability of event B minus the probability of event A or B. So we got some fractions here. We have a third plus a fifth, and we're supposed to take away a tenth, and I feel like doing this old school. The LCD for these 3 numbers would be 30. 1/3 would be 10/30ths. You can also push buttons. This would become 6/30ths. And we're going to take away 3/30ths. So 10 and 6 makes 16. Take away 3 is 13. 13 and 30 chance. And you can push buttons. I'm too tired to judge you. Now, what do we have here? We have a given, right? So let's write out the given form. The probability of A given B must be the probability of events A and B sitting pretty over the probability of event B. And I have given you the given. So it's 5/7. I'm plugging in, I'm substituting. 5/7 must equal the unknown probability of events A and B sitting pretty over the probability of event B, which is 7/10. Now, I know you guys are going to use decimals, whatever. You do you, okay? I'm going to 7/10 both sides. 7 times 5 is 35 over 10, which is 70. And that would equal the probability of events A and B. And 35 over 70 is 1/2. So 1/2 is the probability of events A and B happening. It's the overlap or whatever. There you go. Assume you have a deck of 52 cards without replacement, which means that you take a card out, and that's what you do. Find the probability of drawing an ace, a queen, and another 2 in that particular order. You could do this with permutations, and I might pause it and think about how to do it real quick with permutations, but there's no need. There really is. It's actually worth thinking about, because like I said, I'm not a huge fan of permutations. It's something I need to get better at. But anyways, there's gonna be 4 aces in a deck of 52 cards. And I've pulled a card out, so now there's gonna be 51, but there's still 4 queens. And now I've pulled a card out, so there's 50 cards. And I'm getting a 2. At this moment in time, there's 4 2s, but I'm pulling it, so there's 49 cards, and there's only 3 2s left. So it's not that bad. It's not that bad to approach from a classical strategy of just thinking about what's happening. All right, so along the top, we got 4 times 4 times 4 times 3. I just went brain dead here. Should be 192, I think. Yeah, it's 192. I can do the top, I can't do the bottom. That's 192. Bottom is 52 times 51 times a 50. It's almost like a factorial there, isn't it? But it doesn't keep going, times 49. Big old number. 6,497,400. Let's see if that reduces. I'm sure it does. They're both even numbers. Calculator, though, can't do it. Okay, so I guess I could do it by hand if I really felt like it. I just don't feel like doing it. Let's move that decimal 5 places, or let's multiply by 100. Calculator will clear it out that way. There we go. 0.00296. All right, now I'm gonna pause for a second and think about how to do this with permutation. I've got just a few minutes before fifth period starts. All right, so I did spend some time here, and it's not my default, but particular order is mentioned, so that means I'm dealing with a permutation. That's kind of the kicker. If somebody mentioned order, it's gonna be a permutation. Now, you're picking one ace of 4, so you have a 4, pick 1. You're picking one ace of 4, another 4, pick 1. A 2, and at this moment in time, it's a 4, pick 1, and then, but you've pulled a 2, a 3, pick 1. And you could probably make this into a 4, pick 2, and it'd probably be the same thing, but I'm still thinking about what's happening. Now, the bottom is that I picked 1, 2, 3, 4, so it's going to be 52 cards, pick 4. And it's incredibly lazy, and it's actually probably harder than it should be, but you can type it all in at once if you want. 4, math, probability, pick 1, times, times 4, math, probability, pick 1, times, where am I at? 4, pick 1 again, 4, math, probability, pick 1, and then times 3, math, probability, pick 1. All sitting pretty over 52, pick 4. 52, math, probability, pick 4. Whew. Same decimal. You see it? So there you go. All right. And that's what I have time for. So anyways, there's the first part.